Hello and Assalamu alaikum students. Let me introduce probability distribution to you. Probability distribution is the probability or the chances of a certain outcome to occur in a statistical experiment. Means that if you are performing a statistical experiment, there are chances of various different outcomes to occur. So the probability or the chance of each outcome to occur is called as the probability distribution, and these distributions can be expressed or explained with the help of a function or a mathematical formula. That formula is called as distribution function, but in this short video we will not look at the function, but we will just look at some probability distribution with a simple example. Now let us roll a dice. This is an example where I can show you the probability distribution in a very simple way. So let's roll a dice. If we roll a dice, there are different possibilities of outcomes. So the possible outcomes in this case, in a simple experiment of rolling a dice, there are how many possible outcomes? Can you guess? Yes, there can be 6 possible outcomes. So the possible outcomes are 6, and what those outcomes are, this can be 1, 2, 3, 4, 5 and 6. Very simple, right? So these are the possible outcomes when we roll a dice. We can either get 1, we can get 2, we can get 3, we can get 4, 5, or we can get 6. So there are 6 possible outcomes, and each of these outcomes have a certain probability associated with it. Means that there are certain number of chances for each of these numbers or each of these outcomes to occur. For example, what are the chances of 1 to occur, what are the chances of 2 to occur, and similarly for others also. So for a fair dice, means a dice that has even mass distribution in it, and it's not heavier from one side and lighter from the other side. In that case, it will make it a biased dice. So we are talking about a fair dice here, which has uniform mass distribution that rolls in a free way. So in that case, each of these outcomes will have equal number of chances to appear as an outcome, or these outcomes will have equal probability to occur. And how can we write that, and what will be that probability? That will be 1 out of 6. So this outcome has 1 out of 6 chances. This 6 is the total number of outcomes or total number of occurrences, the possible outcomes. So this one has 1 out of 6 chances to occur as an outcome. This second one also, third, fourth, fifth and sixth, all of them have equal probability to occur as an outcome, right? So we can plot this probability also. So in order to plot that, we just use bar chart to plot them. So each of these outcomes have equal probability to appear. That is why this graph or this graph will look like this one, and this is called as probability distribution. So the probability that is distributed over these outcomes, each outcome has equal number of probability to occur as an outcome. So this is a constant type of probability distribution where there is no biasing towards one of the outcomes. So all outcomes have equal number of chances to appear. Now let us make it a bit more complex, in which we roll 2 dice together now. So when we roll 2 dice, there is a possibility of outcomes on each of them, right? So we can take sum of both outcomes, means sum of the outcomes on dice A and dice B. So when we do that, there are several different possible outcomes in this case. So what are those? If we say that the sum of two dice is x, means that when we roll two dice and the outcome of one and the outcome of dice second one, we add them together and we call them x. Then we have these different possible outcomes. It can be either 2, because the smallest number of each of these dice is 1, so the smallest possible sum can be 2. And there can be another outcome can be 3, 4, 5, 6, 7, 8, 9, 10, 11 or 12. So there are 11 possible outcomes when we roll two dice. But here, in contrast to the previous one where we roll one dice, here when we roll two dice, there are different probabilities associated with each of these outcomes. And what are those? These are this one. So that outcome 2 has 1 out of 36 chances, or 1 out of 36 1 over 36 probability. It is the probability of x to appear is expressed like this. It is mentioned like this: P stands for probability and x is the one of which probability we are calculating, means the probability of x. This is one of these x outcomes. So probability of 2 to appear is 1 over 36 and probability of 3 is 2 out of 36. But how do we know that it is 1 over 36, this is 2 over 36, and so on? 7 is 6 over 36 and 12 has a probability of 1 over 36. We know it from this table. We can find it out from this table when I explain all of these possible combinations for each outcome. So for the outcome 2, the dice A and dice B can has this combination. This is the only combination with which we can get 2 as the outcome, or the sum of two dice is 2 for this combination only. And while for 3, if we get 3 as an outcome, there are two possible combinations. So dice A can have 1 as an outcome and dice B may have 2, or dice A has 2 and dice B shows 1 on the outcome, right? So there are two possible combinations for 3 as an outcome, and 4 we can have 3 different combinations like this one: dice A shows 1, dice B shows 3, or dice A shows 3 and dice B shows 1, or dice A shows 2 and dice B also shows 2. So these are the 3 possible combinations which will give us 4 as an outcome of rolling 2 dice. Similarly, 5 can have 4 different possible combinations of that can give us 5 as an outcome, and 6 has 5 different combinations. So you can count, you can do you can also try yourself to find out all the different possible combinations for each of these outcomes. Similarly, 7 can has 6 different combinations that can give us 7 on the outcome. 8 can has 5 combinations, 9 can has 4 combinations, 10 can has 3 combinations, 11, 2 and 12 can has 1 combination only. So from here, if we count all of these combinations, so this is 1 combination, this is 2 combinations, 3 combination, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we count all of these will make 36 possible combinations. So there are 36 possibilities in rolling 2 dice together. So out of those 36 possibilities, each of the outcome has a certain portion of it. So 2 has only 1 possible combination, so it has 1 out of 36 possibilities, or 1 over 36 probabilities. Similarly, 3 has 2 possible combinations, so it has 2 out of 36 probability, and 4 has 3, 5 has 6, and 7 in all of these has the maximum. It has 6 out of 36 probability to occur on as an outcome. So here you can do an experiment yourself also, but when we have this, when we find this out, we can plot a probability distribution graph. How we can plot it? We plot in a similar way we did for a single dice roll. We can plot it like this: the probability for each possible outcome. Here you can see this is a very clear graphical representation that 7 has the maximum chance to appear when you roll 2 dice out of all the combinations and all the outcomes. You can do it yourself. You take 2 dice together, roll them, and note the outcome every time you roll them. So you try 100 times, and then at the end you will notice that when you plot this type of graph, you will see that the number 7 will have appeared, the number 7 would have appeared most number of times than any of the other outcome. So if you find time, try to do this activity. It will be fun for you. So the names of these probabilities and further details about the probability distributions and other different types of probability distributions we will study in next lectures, inshallah. Thank you very much. Have a good time.